This is just I took it from the textbook. And the operating system is a resource manager. As we have seen, everything is possible by the operating system. It does it through virtualization. And now the operating system is a resource manager. Virtualization allows multiple programs to run and share the CPU. How it does, we will see. Okay, how a multi-program, if you have one CPU, one processor in your laptop, how multi-programs are running. So we will see. So virtualization is the answer. That is the magic. So virtualization allows multiple programs to run and share the CPU. Concurrent access to instructions and the data is also possible, allowing memory sharing. We will see it also. Virtualization also enables many programs to access device and share disks. This is also the same as we have seen, virtualization of memory. As a result, the operating system is commonly known as resource manager. CPU, memory, and the disks are system resource managed by the operating system. Efficient, fair, and various other resource management goals are the responsibility of the operating systems. So efficiency, fairness, and various other resource management goals are required. The operating system allows many programs to run and share the CPU. Many programs to concurrently access their own instruction and data as well, and sharing memories, many programs to access devices, sharing disk. So how this magic happens, we shall see. So to show you this, what we are going to do, we will go to the Linux. So if we use command top, okay, then if you click one, in this particular case I have 4 CPUs. Okay, I have 4 CPUs, and as you can see, a lot of programs are running. Okay, a lot of programs are running. So this is the magic. We have one CPU, one central processing unit, okay, AMD or Intel type, which is installed in your system. But this is what happens. Okay, this is what happens. So let's continue. So in reality, the system mostly have one processor. However, the system has a very large number of virtual CPUs. That is virtualization. That's why a lot of programs are running at the same time. It seems like that, but we will come how does virtualization really work. Turning a single CPU into a seemingly infinite number of CPUs. Okay, one CPU is turned into millions. So that is virtualization. Allowing many programs to seemingly run at once. Once we virtualizing the CPU, when we see here, we think that many programs are running at once, but that is not the case. Okay, that is not the case. When you understand, in the next video I will show you what does it mean, then you will grasp the main idea of virtualization. So this is the main point. So important website, as I told you, just go to GitHub and try to download the codes. Okay, so let's start with our virtualizing the CPU concept. So this code also is free. This code is free, and to show you how virtualization work in the CPU, this is the code. I took it from the textbook. So this is simple code. This code, as you can see, the main function we have here, it takes an argument, and what it does is in fact all it does is call spin. As you can see, it is spin, a function that repeatedly check the time. Okay, it will repeatedly check the time and return once it has run for a second. Then for each second, repeatedly check the time and return once it has run for a second. Then it prints out the string that the user passed in on the command line and repeats it forever. So once the argument is given by the user, then after each minute it will return. Okay. Let's say we save this file as cpu.c and decide to compile and run it on the system with a single processor or a CPU, and we will show you. So what we are going to do, let's go to our Linux. Okay, let's go to our Linux, and what we are going to do is let me list. As you can see, we have all the files, cpu.c. okay, cpu.c is this is a file, cpu.c. So if you want to see, the code is there. So what we are going to do, for example, okay, cpu.c. As you can see, the code is here. Okay, the code is here. So as we see, the main function is here. It will check here, and so let's go ahead and see what's. Let's compile it. So what I'm going to do, gcc cpu at cpu.c. So as you can see, gcc what we are going to do, let's invoke the cpu.elf file. Okay, so as you can see, we have the string, so let's invoke it now. What I'm going to do, cpu.elf. So let's pass in an argument now, say a. Okay, let's pass an argument a. So as you can see now, so a, it's executing because we pass a, it's passing a only. So control, this is because we have one processor, so one process is running. Now let's continue to the second, and let's give two arguments in this time instead of a. Okay, instead of only a. So let's make let's give two. Okay, let's make two process. For example, what we are going to do, cpu.elf a, and in this time we are going to give two. Okay, cpu.elf b. So let's run it. Now as you can see, we have two processors running, A and B. Okay, A and B. How this happened? That is the point. How this happened? Because we have only one CPU, but at the end of the day, as you can see, it is 2 now. Okay, so 2 processes are running. This is the magic. This is the magic. So let's go back again, paste, as I showed you now, GCC CPU.else, and you are advised also to follow me like this, because if you practice, it's good for you. If you practice, it is good for you. And instead of 2 now, for example, instead of 2, let's give for example 4 arguments. Okay, let's give 4 arguments. For example, CPU CPU.else A, and let's give another CPU B, okay, B, and CPU.else C, and CPU.else D. So now I give four processes. As you can see, this is the process PID. All the processes are running. How this happen? This is a huge magic. So this is virtualization, because each program, each process, when it runs, it assumes it has its own processor. So that is the idea. So let's go back and so just download all the files. It is open source, as I told you, and let's invoke it again, because I don't know why it doesn't stop for me. CPU.c, so ps a grep CPU. Just I want to show, as you can see here, how many processes we have. 0, 1, 2, 3. Okay. So in this way, you can virtualize the CPU. What I showed you now, until now, what I showed you is what I showed you now. What we have seen is the virtualization of CPU. Okay, virtualization of CPU. So in the book, as you can see, running forever only by pressing Ctrl C, we can alter this program. So this is the virtualization of the CPU. So mostly in this chapter, what I want to discuss, as we have seen 4 processes, A, B, C, D, they were running only in one. So virtual CPU illustration 4. How does this magic happen? Because 4 processors are running. That's what I wanted to show you. Despite having only one processor, all 4 programs seems to be running at the same time. Operating system and hardware work together to create the illusion of a large number of virtual CPUs. So despite having only one processor, all 4 programs seems to be running at the same time. This allows multiple programs to run simultaneously and efficiently on the single processor. Virtual CPUs enable multitasking and improve system performance. The operating system is responsible for managing and scheduling tasks on these virtual CPUs, turning a single CPU, a small set of them, into a seemingly infinite number of CPUs. This is virtualization, thus allowing many programs to seemingly run at once is what we call virtualizing the CPU. The focus of the first major part of this book is virtualization. Even though we have only one processor, all four of programs seems to be running at the same time. So that is what we have seen in the Linux.